The first speaker is Dean Radin, PhD from the University of Illinois. He is now the chief scientist at IONS, Institute of Noetic Sciences. He's known for his work, a long-standing career in parapsychology, including presentiment and mind-matter interactions. He's the author of 3 books, The Conscious Universe, Entangled Minds, Supernormal, and the title today?
The one on the slide.
Consciousness and the Double Slit Experiment. Please welcome Dean Radin.
The title of my talk in the program is a lot longer, so I just made it shorter so it would fit on the slide. I assume by now everybody knows a lot about the double slit experiment, so I'm going to go through this very quickly. If you take elementary particles, quanta, photons, electrons, and so on, you send them through 2 slits, and you look at a screen to see what happens. If you don't know which of the 2 slits the particle went through, then you get an interference pattern. And this, of course, works just as well if you're sending a single photon or single electron at one time. The mystery is that as soon as you do know, by any means, which of the 2 slits the particle goes through, then you get a pattern that looks like it's particles. This is, of course, leads to the famous wave-particle duality. And in a much more practical sense, it leads to this sort of thing. The caption says, it says the cost of the flight went up because we acknowledged its existence. So there's something peculiar about observation. And this is, of course, the quantum measurement problem, which has been described before here, but I'm going to do it in a simpler form. You have some sort of a system, which could be a double slit, any kind of physical system, some sort of measuring apparatus. And the measuring apparatus does an observation of the system. From a quantum perspective, you take the tensor product between the 2 quantum systems, the 2 physical systems, and you end up with a system and the measurement apparatus no longer being independent. So we can say that the 2 physical systems are entangled. So from a quantum perspective, we're just dealing with complex waves. There's no particle-like behavior yet. John Bell made this sketch to illustrate the problem. Well, where does the measurement end? So if you imagine that you have a photon and it goes through 2 slits and it hits a screen, you might have a photodetector, and then you might have a human a counter that looks at the number of times that the photodetector goes off, and then the human eye and the human brain. All of those are physical systems. All of them are therefore quantum. Well, why do we see a particle? Why does observation make a difference? So this is sometimes called the von Neumann chain or the Heisenberg chain. Where is the cut made? When does quantum become classical? John von Neumann said that the measurement chain ends only when knowledge of the measurement is registered by what he called an extra-physical factor. In other words, you can't use another physical system to end the chain because it just becomes more quantum. So you need something extra-physical, by which he meant consciousness. And he wasn't alone in his opinion. Almost all of the founders of quantum mechanics said something like this in various ways, but go all the way back to Bohr and even Planck. They all said something like this, and this continues to the present day, as you know. This is today a minority opinion within physics, but nevertheless, it has a pretty prominent background. So I've been aware of this, of course, and everyone offers theories about consciousness, but nobody does anything about it when it comes to this particular problem, the measurement problem. So what we did in the laboratory is we built a double slit system, and fortunately it's a very simple type of a system. You have a laser, you have a filter, you have a double slit, and you have a camera that looks at the result. So the only new element in this experiment is that we ask people, in this case like a meditator, to keep the double slit in mind and to imagine in their mind's eye that they could see which of the 2 slits that the photon went through. This is, as far as we could tell, the only way of directly testing whether consciousness is actually collapsing the wave function. So this is what the apparatus looks like. The tube sticking out of the long box there is the far end of the helium neon laser, and the double slit and the camera are inside the box, so it's a sealed system. You can't see it with your eye. You can only use your mind's eye. This is the camera. It's called a line camera. And this particular one is 3,000 pixels long in a line. And what the camera sees is an alternating band of light and dark. This is the interference pattern. When you look at this in software, you can say, well, how bright is each band? And you get a picture that looks something like that. Does that show up? Yeah. So you get this sort of Gaussian-looking shape. And that's the way of looking at the interference. So if we start with that pattern in picture A, you can do a Fourier transform, which is picture B, and the peak in the middle is now the double-slit spectral power. And this is the way we initially started doing these experiments, with looking at the power spectrum. And this is convenient because, again, we ask someone who, in this case, in the laboratory is 2 meters away from the sealed optical system. We ask them to keep the double slit in mind. And then the measurement is very simple. We predict that if observation is doing something to the interference pattern, that the double slit component of that interference will go away, or at least it'll go down. In addition, because this is an abstract task, the double slit itself is about, each slit is 10 microns across. And if you just simply hold up the double slit to somebody to have them look at it, they may or may not even be able to see it. So it's difficult for some people to imagine that they can, in their mind's eye, see what's going on in that space. So we do a real-time analysis of the double slit power, and we use that to adjust feedback tone. So if you have somebody doing the task, they could look at a screen, which is showing a signal, or they can simply do it by listening to the tone. And generally what we do is we have like a droning tone, and we ask the person to make the droning tone louder, make it just louder, because it's a very pleasant tone. And then that if they would know that they were succeeding through that tone. This also provides a way to focus their mind on the task at hand, because mind wandering is always a big problem. The protocol is very simple as well. We compare the double slit power during mental observation versus no observation. They get a voice message which says, now concentrate, and then now relax, and this alternates. We do the observation periods for 30 seconds, and the rest periods are 30 seconds, plus or minus a random 5 seconds, for reasons I'll mention later. This is repeated in a typical session 40 times. So the whole session lasts 20 minutes. And the measure that we're interested in is a differential measure. We're asking, what is the double slit power while observing versus while resting? So that, and there are many ways of doing the statistics. We generally present it in terms of a z-score, or an effect size. So we did our first experiment in this form. This was for 35 sessions, 20 minutes apiece, 15 people contributed it. Overall, you can see the mean and 1 standard error. We did actually pretty good. Meditators did a little bit better than the non-meditators. And the prediction was that the double slit power would drop during observation, and indeed that's what we saw. So when we do experiments of this type, especially when they work the first time, we're always suspicious about the first timer's effect, or everybody's very enthusiastic about what's going on. So we repeat it again and again. So we did 4 pilot studies, each time adjusting things in various ways and looking at different kinds of aspects of the design. And in each case, each one of the 4 pilot studies, the meditators did quite well. If you just combine everybody, the green dots are the overall result, and in some of the experiments, the non-meditators did not do very well. They tend to mind wander pretty quickly. So there's as you remember, there's a 30-second period where you're asked to do this abstract task of putting your mind in a box at a distance. And they can do that for about 4 seconds, and then they can't do it anymore. So the overall result of the pilot studies was this. You see, again, overall, we got a pretty nice effect. Meditators did quite well. Non-meditators overall got actually close to chance. And we ran the same system. And this, by the way, was 250 20-minute sessions, 137 people. And we ran the same system again and again as controls, which are the white dots. And we don't see any artifacts within the hardware or software or analytics that would suggest that there's some kind of bias in the system. So here it looks like observation was collapsing the wave function. At least the meditators could do that. And the control tests, we don't see any effect. So we were encouraged by this to go ahead and do a formal experiment, formal in the sense that we pre-specified how many sessions we would do in advance, so 50 sessions. So here's the result of the 50-session pre-planned experiment using the same analysis that we had used in the previous experiments. And this gave us a 5 sigma result. So for those of you who are not used to the term sigma, think of it in terms of z-score. It's the same thing, standard normal deviate. So we got a 5 sigma result when people were observing, and when nobody was doing the observing, we got almost exactly chance. When we do an experiment like that and we get a very strong result, if you keep in mind that a 5 sigma result was able to give CERN the Nobel Prize for finding the Higgs particle, which turned out not to be Higgs after all. Well, we got a 5 sigma result too, but I haven't heard from the Nobel Prize Committee yet. And we were also suspicious of it because that seemed way too good. So we did another formal experiment. Again, 50 sessions. We did other things I don't have time to talk about on this. But one of the things I'm showing here now is this is the control results, and it's lagged in time. And the reason why we look at the results lagged in time is because if you ask somebody to now concentrate, and then a little while later, now relax, you can't switch your mind instantaneously. So we expect that there should be a delay in the results of the experiment because it takes the mind to switch gears. So this provides actually a nice secondary way of looking for the results that we hope to find, because if there is no delay, then you have to be suspicious about the results. So here's time 0, which is when the instruction is given to switch your attention. There's the experimental results with the lag from 0 to 15 seconds, and in fact, we got a slightly better result with 2-second delay. So I'm not going to talk about this analysis again for the remainder of the experiments, but we did this sort of lag analysis in all of the studies that we've done. So after doing the second formal experiment, again getting over a 5 sigma result, we got suspicious. So maybe this was caused simply by proximity of the human body. Even though it's 2 meters away from the double-slit system, we figured that maybe when somebody's asked to concentrate, they lean forward slightly. And for those of you who've worked with interferometers, you know that they're exquisitely sensitive to everything. So we thought maybe the temperature change from a body 1 inch closer versus 1 inch away would be sufficient to make this result. So we decided to put the entire thing on the internet so we'd be sure that we could rigorously separate people by distance. So there's the double slit. This is sitting on a rack that has a bunch of servers on it. And we ran this for 3 solid years, calendar years 2012, 13, and 14, ended up with over 5,000 sessions done by human observers and 7,000 done by robot observers. And I'll explain what that means in a minute. So when somebody would sign on to our website, this was a public site, by the way, we got people from around the world to do this, in a non-observing condition, what you would see is this blue rectangle on the browser screen and simply saying, please relax. And you'd hear no sound. And then it would switch. You'd hear a voice saying, now please concentrate. And then you would start seeing this line move along the screen. The instructions were to make the line go up. And you would hear a kind of a whistling sound that was a tone. And the tone would go up and down as the line went up and down. And we did that so, again, you could do this experiment with your eyes closed. There were also lots of checks and balances built in here. We knew, for example, if somebody left the experiment while it was going. And we would then we'd restore all the data, but we'd mark it as this was an experiment that was not completed by a person. For what we call the robot experiment, it was a Linux system which was designed to simulate a human. Now, the beauty of this is that everything was exactly the same as far as a double-slit system was concerned because it didn't know, we think, it didn't know whether a human was looking at it or a Linux system because they both came through the internet in the same way. So we have very nice control for human observation versus we don't know whether a Linux system is conscious or not, but if it is, it probably doesn't have the same level of consciousness as a human. So here's the interference pattern. This is the central portion of the interference pattern that the camera would see. What we did on this was a simpler measure than we did before, and this is called fringe visibility, which looks at a peak and a trough, and it measures the relative difference between the two. And this is nice because if you work with lasers, you know that they're not amazingly stable. Some of them are more stable than others. We were using a helium neon gas laser, which is known to do things like mode hopping. Power levels will slightly change. And you have to jump through some statistical hoops in order to reduce the effect of that mode hopping. But for fringe visibility, you don't need to worry about that so much because this is now a relative measure and takes into account that there may be fluctuations in power. So it's a more sensitive measure as well. So the prediction is fringe visibility while you're observing would go down. So it's somewhat similar to expectation that double slit power would go down. In this case, it's fringe visibility. So this is the result of the sessions in 2012. There are 2,303 sessions done by the Linux system. These are the middle 20 fringes of the interference pattern, and it shows in terms of z-scores where it was. There's one or two of them that were around 3 sigma, but overall it was pretty close to chance. And this is what we got with human observers. So some, again, approached 5 sigma differences. That was 2,089 sessions by 689 people around the world. So what's nice here is they're able to look at yet another issue, which is, does distance matter? So this is the distribution of the effect sizes from where we were in California to the farthest that you can get from our laboratory, which is South Africa, which is 18,000 kilometers away. And so we did a linear regression. It turns out to be flat to 6 decimal places, but not null. It actually, that line looks like it points at 0, but it's below 0. That's why we end up with a significant effect. So the observer effect is independent of distance. We then, again, in every case when we do an experiment and get a result like that, we don't believe it ourselves and have to replicate it just to convince ourselves that it's real. So we did it again the calendar year 2013 and 2014. So here are 5,700 sessions of the controls. So this is now a cumulative deviation plot. So cumulatively, you should expect that the deviations that you see in this experiment should sort of hover around 0. There shouldn't be any systematic deviation, and there isn't. There's a slight positive movement in the 2013 data, but not in 2014. This is the controls. Then we look at the experimental results. So in 2013, we got a cumulative march towards fringe visibility dropping, which is what we had seen before and what we had predicted. But 2014, it just kept getting more and more positive. And this was a big puzzle. As far as we could tell, the system was the same. It's turned on and has left on for the entire year. It's never turned off. The program is the same. Everything was the same. And when you do the statistics on it, sure enough, it completely reverses. So this was a big puzzle. It took about a month for me to figure out what was happening here. And the reason why it reverses this, that when you think about conventional coordinate system, because remember that the way that we present the feedback here is a squiggly line that moves on a graph. And going up on the graph was linked to feedback that fringe visibility was dropping. So that's the way that we had set it up in 2013. In 2014, we decided to slightly change it a little bit with the hopes of making the feedback a little better. But we forgot something. A conventional Cartesian coordinate system looks like this, but in Adobe Flash, it's upside down. And we wrote the browser, the client program in Flash. And we forgot that you have to reverse the sign. Well, why does Adobe do that? It's like it's backwards. Well, it's because it goes back to the old days when we had CRTs with a raster scan, and it would start from the top and go down. And so they left that code in to the Adobe system, and so you simply have to remember that you need to reverse signs, which we forgot in 2014. So it meant that in 2014, the feedback was reversed, and the results were reversed. So this suggests that the observational effect we're looking at is an active effect. It's not simply that consciousness collapses the wave function, but it more is that it's something like a quantum Zeno effect, and it steers the direction that you're going. So when you take the overall results from 2013 and 14 and you reverse the sign of the results in 2014, you get a very healthy result for people and very close to chance for the robot sessions. By the way, all of this data, it's about 80 gigabytes of data. It's millions of camera frames with the interference patterns. It's being put online as we speak and will be available eventually when all of that data is uploaded, so anybody can look at it. So now a skeptic could say, but is this really a quantum effect, given that you're dealing with a gazillion photons per second with a continuous beam laser? To which I replied, that's a good point. Let's do the same experiment, one photon at a time. So we used a commercial system. It's a little over 1 meter long. And you can shoot a single photon at a time and then see whether or not you get interference with a double slit system. On the right end of that long chamber is a photomultiplier, and that's what detects the single photons. So the way to do this, since you're measuring one photon at a time, is you set up what the photomultiplier looks at, and then you move it a little bit, you move it a little bit, you move a little slide, so you're only getting a little piece of the interference pattern. And as you move that back and forth, you can actually trace out an interference pattern, and that's what you see here. And you see by the error bars on it that it's very tightly controlled. So in this case, we decided to have observation linked to one of the troughs. Now, the trough exists in this case because of destructive interference. So we figured that if observation is getting rid of the interference, then photons should increase in this case at that point. So we set up the system to look at that point with the prediction that when people observe the system, the line would go up. We did 6 experiments, and I'm just going to mention one briefly. We call this the illuminated Buddha experiment because we have a little Buddha statue and put an LED in it that would get brighter the better you did. And the experiment was done in complete darkness. There was also tone associated with this, so you could do it with your eyes closed, but this turned out to be a very pleasant kind of thing to do because in complete darkness, the LED would light up this slightly yellow-colored Buddha, and it would glow yellow, and it was a very pleasant experience. We found actually in all of these experiments that if you think of this simply as Physics 101, it may or may not work. We spent a lot of time making sure that the individuals that we chose were comfortable and understood the design and gave them a lot of leeway in terms of how they wanted to mentally interact with the system. So the psychological side of this is just as important as the physical side. So this is the result with the illuminated Buddha experiment. We predicted that that would go up, and it went up by 2.5 sigma. So that was good. We published this last year, and it's got a prize for the best paper in that journal. So we've done 17 experiments of this type, most of them, 16 of them, using a double slit system over 8 years. And you can put this into a meta-analytic software, and the bottom line is this. Depending on whether you use a fixed effect size or a random effect size, somewhere between around 4 to 8 sigma effects. So it looks pretty robust. And all of this is still predicated on the idea that we're expecting a drop in double slit power. So in the case of 2014 on the online system, actually the results went in the other direction. So I'm not taking into account variance effects. This is simply a mean shift. And in mean shift terms, it's still 4 to 8 sigma. You could then also ask questions like, is this due to p-hacking? Well, no, it's not due to p-hacking. Are the results due to selective reporting? No, they're not due to selective reporting. There's lots of nice software now that you can use data that goes into a meta-analysis and start asking these questions about questionable research practices. And of course, we knew what we were doing. We knew not to do selective reporting and not to p-hack and not to do a whole bunch of things. But it was nice to see that the software confirmed that that was the case. So we so far have 2 independent reanalyses of our online data from 2013 and 14. Nicholas Tremby is a PhD postdoc in physics who's in France, and he came to visit us for a month, and we gave him the 80 gigabytes of data and said, see what you can get. So he was able to confirm that the results that we reported in that paper, which just came out this year, was correct. And a second analysis was done by Wolfgang Baer, who's a physicist in the United States, and he independently verified that the results were correct as well, and he did publish that result. in terms of replications of the experiment, there is a physicist at the University of Sao Paulo who I don't have permission yet to say who he is, but he's doing a replication. I actually sent him our little double slit itself. It's like a $200 piece of metal. So I sent him that, and then 2 days ago I asked him, well, how's it going? I didn't hear about any results yet. So this is exactly what he wrote in an email. And the last days, it has been an intense mixture of feelings. I'm oscillating between, oh my God, and wait, something must be wrong. And this, by the way, is pretty similar to the results, to the same feelings that we had when we were doing these experiments, because you don't often get results that are 5 sigma in any experiment, but it was showing up here. So the reason we kept doing replications is exactly the same sentiment that this physicist is saying. So he's going to visit us starting next week, and will remain for the month of May, and we'll go over in fine detail of his analysis and his methods to see whether he should be leaning towards, oh my God, or something must be wrong. What are other explanations for the results that we've been seeing in this? Well, first of all, maybe there's something idiosyncratic about the apparatus that we used. Well, we've used 4 double-slit systems. We get pretty much the same result in all of them. Vibration is always a problem when you're dealing with interferometers because it's extremely sensitive to vibration. Most of our experiments were conducted inside our electromagnetically shielded chamber, which is solid steel, double-walled, and 2,800 pounds. So normally you'd have an optical table, a very heavy one, that would damp out vibrations. In this case, it was as though we were running inside an optical table, because 2,800-pound table is very good at damping out vibrations. Another problem that may result is that since we're using 30-second segments, that if power happened to fluctuate in a 30-second period, you can end up with an artifact. And this is why we use random timing on the non-observation periods between 30 to 35 seconds to decouple, so that in case there was an external cycle, eventually it would wash out because we were no longer exactly at 30 seconds. Signal drift is always a problem as well. It was very small changes in temperature will cause interferometers to change, so when necessary, we would detrend the data. We measured temperature at the laser itself, the double slit, near the human, with multiple thermocouples, and we didn't find any effect due to temperature. We were very careful not to use parametric statistics on this. All of the stats were based on our parametric bootstrap statistics, which take into account funny business that may be going on in terms of the distribution of data. I mentioned that there are 2 independent analyses so far. We know it's not p-hacking, we know it's not selective reporting, and independent replication is underway. So common questions on this that arise. How do we know that the participants are actually performing the task? Well, as in any psychology experiment, you kind of have to assume that they're following instructions, but you don't really know. That's why you run lots of sessions with lots of people. In this case, though, because we also have the capability of doing neuroscience, we took advantage of the fact that alpha desynchronization is associated with focused attention. So we predicted, while people were doing the experiment, we took their EEG, and we predicted a correlation between the amount of alpha desync and changes in double slit power. And we, in fact, got a significant correlation of the type that we predicted. How come no one has noticed this before? Well, 2 reasons. One is that no one's looked for it, and the second is that the magnitude is very small. The magnitude of this effect is a very small fraction of 1%. So if you were not thinking that something like this could happen, it would simply look like noise. It's not noise in our case because this is exactly what we're looking for. So what's the response to this so far? The response is this. And the reason is clear. It's because extraordinary claims require extraordinary evidence, and in this case requires dozens of independent replications for people to start believing this, and there aren't any replications yet, except maybe the one in Sao Paulo. So if there aren't any replications, then why should anybody believe me? Well, as Johnny Depp tells us, it's actually not true that there are no replications. If you look at 1977, Abner Shimoni and his team at Boston University did an experiment on the same general idea to see if consciousness would collapse the wave function. And they did some different design. They didn't use an optical system like I did, but they did 554 trials with a 50% chance hit rate, and they got exactly 50%. So they kind of lost interest in it. But they mentioned in their paper that somebody else did the same experiment, and they got a 60% hit rate, which you think might have encouraged them to actually do it again, but they didn't. So it just sat there. In 1998, Stan Jeffers at York University in Canada did an experiment with a double-slit system and got nothing, so non-significant result. But Mike Ibbison used the same apparatus at Princeton, and he did get a significant result. So what we have now are 2 out of 4 tests that were successful, and that's it? Well, it turns out, no, we want more. We always want more. So many of you may be aware that for many years, people have been using electronic random number generators, where the numbers, the basis of the randomness are quantum phenomena, either radioactive decay times or electron tunneling or other phenomena. Like the one in the upper right there is using photons that hit a mirror, a half-silvered mirror, and either go straight through or bounce off to the side, which is a quantum random effect. So people have been using these things for almost over 50 years now. To give an example, 1985, Bob John and Brenda Dunn at Princeton University did an experiment with a random number generator where they asked people to aim high, meaning make the generator produce more ones, or aim low, more zeros, or do nothing as a baseline. And they report highly significant results. And what was the reaction to that? Not good enough. And it's the same suspicion you always get, that it's one laboratory producing a result that is kind of outside the mainstream, so people are suspicious. So a couple of years later, Roger Nelson and I, when we were both at Princeton, decided to see, is it really true there's just one lab showing these results? Well, it turns out over a period of about 30 years that there wasn't just one lab. There were 68 different investigators reporting this in 152 publications. Not just one experiment, but almost 600 and 200 controls. And you look at the overall results on the controls, you get something that's very close to chance in terms of the mean shift. And in terms of the experimental data, almost a 7 sigma result. So there's replications. The same kind of analysis was done again in 2006, bringing it up to date, but only looking at a subset of about half of the studies that have been done using random number generators. And again, the sigma was somewhere between 3.6 to 4 sigma results. Now, the authors of this study suggested that the reason for those results was selective reporting. And they gave reasons why they believe that, and I don't believe it, because I'm pretty well aware of everyone who had reported this, and there simply aren't enough people around to reduce the effect by selective reporting. So what's the overall reaction to something like this? We're saying, would you look through the telescope? No. We don't want to. And the reason is this. So a lot of people have felt, and I've heard explicitly people saying, if this is true, we need to throw away the textbooks. So we can't throw away the textbooks because we know too much already. That is probably correct within each discipline in science. So what do we do with this? I'm going to present the world's fastest analysis of what's happening here. So reductive materialism is predicated on a model that looks something like this. Physics is at the bottom, chemistry, biology, psychology, consciousness is somewhere near the top, but consciousness doesn't mean anything. And from this perspective, the idea that mind and matter directly interact with each other in some way is forbidden. Or at least it's very difficult to think of a way that it could work. Now, Stuart Hameroff has come up with an interesting model, and there are more and more models coming along that suggest there may be a way to stick within the existing scientific paradigm and solve this problem. But the other approach, of course, is to take exactly the same disciplinary structure, but just take consciousness and stick it down there. So it's a new metaphysical base on which we sit. From this perspective, just like in physics where you have electrons that go everywhere up in the pyramid, here we'd have consciousness that starts at the bottom and goes everywhere up. So this is idealism, panpsychism, neutral monism, use whatever your favorite term is. From this perspective, the real puzzle is how do we get from consciousness or awareness into physics? Because if you solve that problem, and there are people working on that too, well, then all the rest of it is perfectly fine. And we don't need to throw any textbooks away, except we're going to throw them away every 2 or 3 years anyway, because that's what happens. They're not thrown away completely, they're just revised. So in this case, mind-matter interaction actually is quite easy to explain. So here's my conclusions then. First of all, the role of consciousness in the physical world can be tested. It has been tested many times in many different ways. The results so far suggest that consciousness plays some sort of an active participation in reality. So we have lots of collaborators that have worked with us over the years and a number of different funders. I'm going to leave this up for a bit. If you want references to all of the studies that have published, including many more studies, you go to tinyearl.com and that spot, and you can find it. It may be that this is the one that Newton missed, and I thank you for your kind attention. Should I switch it over?
Yeah.
Okay.
Let's take one or two while Stuart Kauffman gets ready.
Okay, I'll leave that up.
Excellent work, Dean. Would you be interested in, if there was some grant money available, in doing a meta study that covers all the work that's been done? Because it seems that this is missing because the only meta study was in part, it was not complete.
You're asking a scientist if he'd be interested in funding?
Exactly.
Just say yes.
Okay, good.
Yes.
So let's talk. All right.
Hi, excellent talk. I have just two questions. One is the role of the feedback. You gave always feedback as a tone. If you don't give it, what happens? And the second one is that you found the correlation between alpha synchronization and the effect size, which seems really reasonable. But you also found the effect with the internet, right? And I really can't imagine what kind of mechanism can cause the effect over the internet. What's your explanation?
Did you understand what he said?
The first one is the role of the feedback.
The role of the what?
Feedback.
Feedback, right.
Tone.
So we use feedback in almost every study, mainly as a way to focus people's minds on the task at hand, but also because of transactional interpretations of quantum mechanics. So it's simply an easier way of imagining how a human could interact with a system at a distance through the interaction itself. So the feedback then became the way that the two are connected.
But is it possible the feedback itself is causing this effect?
Oh, would the feedback cause the effect? So when we do a control study, we have it exactly the same. So the feedback is running during the control as well. So if it was an artifact that was caused by the feedback, then it would have shown up in the control studies, and they don't.
And the second question was how it's possible that even if alpha desynchronization is the cause of this effect, when you are doing it 2 meters away, how it's possible to produce the same kind of effect through the internet?
Through the internet?
Yeah.
Well, we don't know. But of course, it suggests that whatever's going on in terms of consciousness is not, it's non-local. You don't have to be in proximity to the system.
Two more questions and we'll move on.
Dean, lovely talk, of course, but you mentioned the quantum Zeno effect somehow guiding somewhere in the middle of your talk. Could you just expand on that?
I thought you were going to expand on that.
Well,
I thought you were going to talk about the quantum Zeno effect.
I will talk about the quantum
Okay,
Zeno
that's
effect,
good enough.
but how
Okay.
does it guide in your...
Well, how does it guide? I don't know. In this particular case, though, it's a well-known quantum phenomena that the means by which you're observing a system can push it in different directions. So in this case, we had feedback that basically reversed what we originally had seen,
Okay,
which
got it.
caused the reversal.
Thank you.
Yeah, so I'm interested in these interpretations of quantum mechanics where consciousness collapses the wave function, but I guess it's just not obvious to me how this kind of anomalous effect provides any evidence for those interpretations over and above evidence that, for example, really boring evidence we already have. Like, if you look at what's going on in the double slit, you get collapse results and remove interference patterns and so on. You might think that's prima facie evidence, but it turns out all the other interpretations of quantum mechanics can accommodate that evidence pretty well. It seems to me that what you have here is, if the evidence holds up, evidence for some kind of mechanism of interaction between brains, human observers, and what's going on in the double slit. But that's independent of the question of interpretation. I would think that all the interpretations of quantum mechanics will agree that if there is some such mechanism of interaction between the human observer and what's going on in the double slit, then you'd get various, collapse-style results. So it seems to me that it's not clear to me this actually gives direct evidence for this kind of interpretation, much as I'd like it to.
Well, remember that the motivation for this was explicitly looking at what von Neumann said about an extra physical factor. So we used the extra physical factor in as best a way that we could think of doing it, and in fact was confirming, at least to a small degree, what von Neumann was basically saying, that it was beginning to cut the chain. Now, why didn't it completely collapse? My guess is because, well, we did see better result with meditators versus non-meditators, so there's something about focused attention that is a critical element. And it's a very difficult task. Even the long-term meditators found it difficult because of the abstraction of the task. But we're looking at other ways of making it easier for people to interact with these kinds of systems, in which case maybe we'll get stronger results.
I'll bet von Neumann meant extra material because entanglement is physical. Please be quick, Son.
Yeah, I'm just curious about the effect of conscious and unconscious processes on this type of experiment. So if you were able to design a paradigm where you could suppress the interaction from consciousness, because the unconscious processes are in place while awareness is rising or is there, let's say, what would be your expectation? So if we manage to suppress it from unconscious processes equally interact, or?
If we were able to suppress unconscious?
No, if we were able to suppress the interaction from consciousness there are various techniques to do that.
Well, we could use things like distraction. We used the simplest possible method that we could think of initially, which is simply to withdraw your attention from the system. And the way we do that in terms of the feedback is you don't get any feedback. So that portion of it is cut. But we had thought of other things too, like we'd have somebody read something on a screen or other forms. The problem with doing strong distraction of attention is that it takes a lot longer to switch back into the task, and we didn't want to do that.
All right. Let's give Dina a round of applause. That was great. All right. Our next speaker is Stuart Kauffman, a medical doctor, a theoretical biologist, evolutionary biologist, MacArthur Fellow, longtime fixture at Santa Fe Institute, and he's written 5 books, Origins of Order, including Origins of Order, At Home in the Universe, and a new one, Humanity in a Creative Universe. He's well known to worldwide. Stuart Kauffman. You're all set.
So I just to go forward with this. Well, first of all, I'd like to thank Stuart, as everybody else has. Stuart, thank you. But also Abi. Undoubtedly, this would be complete chaos without Abi. So, Abi, thank you. So, I want to try to talk about a set of ideas. It includes my own try as a fruit fly geneticist to have an interpretation of quantum mechanics. Part of what I want to do is take on Descartes and answer him. And part of what I want to do is try to persuade you that quantum mechanics is probably associated with mind and brain. And if it is, then Dean's results are explicable through non-locality. So let's see if I can make this go forward. So can everybody see it okay? So we all know Descartes, 1640, and he's trying to set the framework for modern science, and he comes with his substance dualism, res cogitan and res extensa, where res extensa is the mechanical worldview that later became Newton. Res cogitan is thinking stuff. This is a stuff dualism, but it fails. And why has it failed for all of these years? And in fact, we've been stuck with Descartes for 350 years. And the reason is really due to the causal closure of classical physics. So picture Newton's laws, the billiard balls bouncing on a table with F is equal to ma and the second law, and the third law, for every action there's an equal and opposite reaction. Then ask yourself the following question. If we know the current position and momenta of all the balls on the table, is that sufficient by integrating Newton's equations to determine precisely the next positions of the balls? The answer is it is. Even in the case of deterministic chaos, where there's prediction errors due to positive Lyapunov exponents, the system is completely deterministic. Therefore, for 350 years we have said There's nothing for mind to do. Is it supposed to make the balls move in a different direction? Worse, I haven't said it right. There's nothing for mind to do because the physical situation is already sufficient for the next state of the balls. We don't need mind to do anything whatsoever. Then the next question becomes, but how could mind do it anyway? Is it supposed to make the balls move in some different way? And the answer is no, it can't. So that's why we've been stuck here, and the pineal gland didn't do it. But there's a second issue, which is, I think, absolutely fundamental and missing from most of our discussions, and missing from Dan Dennett's reasoning about could. That's a fun story that I won't tell you. I think most of us believe that the following is true. You could, sitting in your chair now, decide to stay in the chair, or you could decide to get up and walk out of this talk saying to yourself, this guy Kauffman is nuts, and that's probably true. And in that case, a minute from now, the world will be different. In one case, you're sitting in your chair. In the other case, you've gone out the door. But for that to be true, it must be true that the present could have been different. But could have been different is a statement contrary to fact. It's a conditional contrary to fact. Our notion of choice, unless we're philosophers who are rigid reductionists, our notion of choice specifically demands that counterfactuals could sometimes be true. That's impossible in classical physics. All that can happen due to its determinism is what actually happens. It could not have happened otherwise, given the initial and the boundary conditions and the laws of physics. So in classical physics, the causal closure of classical physics precludes whatsoever answering Descartes and having free will. Now, that does not preclude that a classical physics brain, so now we really want to make a point with respect to all of the marvelous neurobiology we're hearing. Nothing at all prevents us supposing that a classical physics brain at some complexity has emergent consciousness. Nothing whatsoever does, any more than we are precluded from thinking that a computer could be conscious. The trouble is, and I think almost everybody knows it, that consciousness could only witness the world, but due to the determinism and the sufficiency of the mechanical system, that mind could not act upon or change the world. It would be purely epiphenomenal. Well, that leads to enormous questions. The tiger is chasing the gazelle. If it's really true that mind is only epiphenomenal, whatever the tiger witnesses in its witnessing classical physics mind, it cannot change what it does. It doesn't help it chase the gazelle, nor does it help the gazelle get away from the tiger. Then why is it that the brain has evolved? Why is it that in fact we seem to be conscious, and in fact we all are conscious? Why is 30% of our energy budget or so devoted to the brain? It makes no sense whatsoever. But you could have an epiphenomenal mind. And I don't want that, and the rest of the talk includes wishing to get around the causal closure of classical physics. So I think the only way to do it is to move to from classical to quantum physics. So I'm persuaded by Penrose that we have to think about quantum mechanics, and I want now to go through, and the whole idea, first idea, is we're going to break the causal closure of classical physics. Without it, we're done, okay? Now, you've already seen, and I suspect by now everybody knows quantum mechanics, and Dean has just shown us the two-slit experiment. So let me just quickly outline quantum mechanics. First of all, there's the two-slit experiment, and Dean's just shown it to you. I take it that everybody knows the Schrodinger equation, but it's a linear wave equation for waves, and the superposition of, not the superposition, but interference is due to constructive and destructive interference, where wave crests or valleys meet one another, or where a crest meets a valley to give you a dark line. I think everybody knows that. Now, the next and truly important thing for my conversation is the live cat and the dead cat, quantum superpositions. They arise because in the Schrodinger equation, it's a linear wave equation. Therefore, if there are two waves simultaneously present, that's called a superposition, and the sums and differences of these waves are also solutions. So there's an infinite number of solutions. And this is the famous Schrodinger cat, simultaneously a dead and alive in the box until we look. So I now want to make a point that I will build on a lot. But meanwhile, I'm going to be supposing that measurement is real and that it collapses the wave function and that it's ontologically indeterminate. That's true on many, but not all interpretations of quantum mechanics. It's certainly true on Copenhagen, but it's not true, for example, on Bohm. So I will be assuming something like Copenhagen in what I have to say. But meanwhile, and before I do, I want to draw an important distinction that I have not written down. Take the statement in English, the cat is on the mat. Aristotle tells us the cat is on the mat, or the cat is not on the mat. There's nothing in the middle. This is Aristotle's law of the excluded middle. Given Aristotle's law of the excluded middle, the statement the cat is on the mat and simultaneously is not on the mat is a contradiction. Well, it is. Now, the cat is simultaneously alive and simultaneously dead constitutes the Schrödinger cat paradox because it's a contradiction. Now, what does a superposition do? It does just that. The cat is simultaneously alive and simultaneously dead, and we are intensely puzzled. So now what? Well, philosopher C.S. Peirce noted late in the 19th century that actuals obey Aristotle's law of the excluded middle. The cat is on the mat or not. He said, but possibles do not obey Aristotle's law of the excluded middle. So let's watch it. This is going to be central to everything that I'm going to say. Possibles do not obey Aristotle's law of the excluded middle. So let's just try. The cat is possibly simultaneously dead and simultaneously possibly dead and simultaneously possibly alive. That's obviously not a contradiction. I hope we all agree. Let me say it again. The cat possibly is on the mat and simultaneously the cat is possibly not on the mat is not a contradiction. So if we use the word possibly, all of a sudden we are no longer obeying Aristotle's law of the excluded middle. It is non-Boolean. It's not just yes and no. I took those two seriously, noted that Aristotle had thought about potentia, that Heisenberg had thought about potentia with respect to the wave function, where nobody knows what's waving in the wave function, and that Alfred North Whitehead had thought about potentia. And I said, well, let's just take it seriously. There are, in fact, therefore, two realms of reality. And I want you to try this with me dead seriously. It does a lot. We think of reality as only consisting in actuals. That which obeys Aristotle's law of the excluded middle. I want to conceive of res potentia and res extensia linked by measurement. I want to try the idea on us that possibilities are ontologically real, and so are actuals ontologically real, and I'll define actually real as it obeys Aristotle's law of the excluded middle, and possibles as that which does not obey Aristotle's law of the excluded middle, then linked by measurement. If you take this, and I will from now on, then what is happening, what is waving in the Schrödinger equation are possibilities. The amplitudes are themselves possibilities. When you square the amplitude, you get a probability, which is the probability upon measurement that that's the wave that's measured. So let's go back to Peirce. Peirce says probables also obey the law of the excluded middle. It's easy to persuade yourself. If you take 10,000 coins, flip them 10,000 times, and ask how many heads will you get, and you say the probability of 4,593 heads is a little teeny bit less than 50%, and you do that experiment millions of times, you'll get a Gaussian distribution whose mean either is or is not centered on the value that you calculated. So the probability statement is either true or false, given that Gaussian distribution. So probabilities are true or false, they're actuals. And certainly the cat is on the mat as an actual. Superpositions are not actuals, they're possibles. Please take in, absolutely seriously, I'm proposing a new dualism, res potentia and res extensia. But res potentia is not a substance dualism because possibilities are not stuffs. Stuffs obey Aristotle's law of the excluded middle. So I am proposing a dualism. And I want again to emphasize it's not a substance dualism. Now, I won't have really time to do this in this talk. My new book tries all of this, and I'm really happy about it. But you know, there's the puzzle of non-locality. If you take possibles as ontologically real, and you take the idea that a new actual acausally alters what's possible, you can explain non-locality, you can explain which-way information, you can explain the delayed choice experiment, and so on. And let me just give you one, not apocryphal, but one that's easy to understand example of a new actual changing what's possible. You and I are going to meet tomorrow at Trader Joe's, and we're going to have, get some orange juice, and they have coffee in the back, and we're going to have a chat. Today, at noon, a sign goes up on the store at Trader Joe's saying, this store closed immediately. A padlock goes up, all of the stuff disappears from the store. What just happened to the possibility that you and I can meet there tomorrow for orange juice and coffee? The possibility vanished. We can no longer meet there tomorrow, and that's exactly what we all think and would say. We can't do that anymore because the store closed. Now ask, did anything causal happen such that the possibility vanished? And the answer is of course not. The store closed, and acausally, the possibility vanished. But other possibilities might have come up. A store could have opened across town, and when that store opened, it could be possible that we go there the next day to have lunch. Changing actuals change what is becoming possible. There's another thing to be said about, much to be said about possible. Enablement becomes a word that we can use, not just cause. Our analyses are always causal, but much of what we do is enablement in our lives, and we speak of them as causes. So I won't go more into non-locality. I just want to say this about Dean's results. If Dean put his observer on Mars and got the same results, those results would be non-local, and we would be persuaded, if persuaded that his results held, that it was non-local. I know this because Dean told me we put an observer on Mars, and it's true that the time is enough, given his experiment, that we could demonstrate non-locality. Is that experimentally accessible? Yeah, within the next 50 years, we could put somebody on Mars, have Dean's grandchild to do the experiment, and we can know whether or not Dean's results hold up for people who are far enough away for it to be a non-local effect. If it's a non-local effect on almost all interpretations of quantum mechanics, it's quantum. Okay, now I think I go forward by doing this. So now I want to tell you that quantum mechanics, remember my move is to get us beyond the causal closure of classical physics. So I'm having a hard time reading this myself. Oh, so on quantum mechanics, non-deterministic measurement, the fact that measurement is not deterministic and real on many but not all interpretations of quantum mechanics, says that the present could have been different. So here I have an electron, and it could be spin up or it could be spin down when measured. Not until measured. I can't assign a quantum state to it when it's not measured. And I measure it, and it comes out that it's spin up. But it could counterfactually have been measured to be spin down. Therefore, if measurement is ontologically indeterminate, the present could have been different. At that moment, the spin could have been up or it could have been down. So we have the possibility ontologically, not experientially, we have the possibility of free will precisely because we have the possibility for counterfactuals being true, which is impossible given the causal closure of classical physics on classical physics. The other thing is the following. If we buy quantum mechanics in that measurement's real and ontologically indeterminate, prior to measurement, it must be possible that the electron be found to be spin up or found to be spin down. It has to be possible ahead of time. Again, ontologically real possibles, which fits precisely what I'm saying, that what is propagating in the Schroeder equation, and nobody knows what it is, are ontologically real possibilities. Otherwise, what do we mean by saying it's possible that it could be head up, or it's possible that that spin up, or possible that it could be spin down? Now, for von Neumann, a sufficient condition for measurement, as Dean Radin just told us, is that the human mind ends the indefinite tangle of entanglement for the measuring device becoming entangled with the quantum variable, then the two becoming entangled with another measurement device, and so on. And Dean's just told us his experiments. And that is to say that in a sense that Dean's just told us, if confirmed, and Dean would say the same thing, mind can, I'm going to use a neutral phrase, mediate measurement. Well, Dean's just shown us. Maybe mind is mediating measurement, and that says what it says. It says that von Neumann's move was right. I'll come back to his epistemic cut later. You've already heard the epistemic cut issue right here. Can you see the little, does it show up? You've just heard the epistemic cut issue. I'd like to come back to that later. Okay, now, the next point, 8, is central to us. We are aware of the results of measurement. For example, the spot on the silver halide screen, the cat is alive or the cat is dead. We never are aware of the superposition. Never, ever, not once. Now, this is the deep puzzle in quantum mechanics. Why aren't we ever aware of superpositions? And it's the problem of basis choice. But the fact remains that we're never aware of superpositions. We're aware of the results of measurement. This suggests to anybody who's not just stubborn that measurement itself must have something to do with mind. So Dean and von Neumann have said to us that mind has something to do with measurement. The fact that we are only aware of the results of measurement suggests that measurement has something to do with mind. So I'm just going to use the word associated with, not cause. In fact, I don't think any of this is causal or need be. So let's try, we've already tried testing measurement has something to, mind has something to do with measurement. That's the results that Dean has just shown us. Could we test the idea that measurement has something to do with mind? Yes, of course we could. So, of course, Stuart Hameroff and Roger Penrose and others are busy trying to do that with microtubules, but there's another way to do it. So I'm a Drosophila geneticist in my past. So I'm going to tell you an experiment that actually can be done, and it may have been done in part. So I take a Drosophila population, those are fruit flies, and they can be anesthetized with ether. It takes a certain dose and duration of ether for them to plop over. It's about a minute and a quarter or something like that. Now, it's a trivial experiment to do, to select on a population of fruit flies for those that don't fall over, or for those that fall over very fast. So let's take those that fall over very fast. They're sensitive to ether. After 10 or 20 generations, I will have a population of selected flies that are incredibly sensitive to ether, and it takes almost none for them to be anesthetized. It's now a standard genetic procedure to sequence the genome of the selected flies in the original population, called the wild-type population, and discover which, if any, proteins are mutant, which, if any, RNA molecules expressed are mutant, let alone up and down regulated RNA and protein, let alone chromatin modulation. All of that's now completely testable. Let's make it simple and say that we find 6 mutant proteins and no mutant RNA. Can we ask where in the fruit fly those proteins are? It's trivial to now do that. This is probably a year's experiment. It may turn out that they're tubulin, and Stuart will be very happy. They're in microtubules. Maybe it will turn out that they're in synapses. Maybe it'll turn out that they're in toenails. I don't know, but we can ask. As a matter of fact, suppose we've done it with ether. Then we could do it with other kinds of anesthetics and ask, is it the same set of proteins or a different set of proteins? No theory, just do the experiment. Suppose it's the same set of proteins. Then we could take fruit flies, so we could take human beings, except that we don't select on human beings, and we could take other organisms, all the way down to E. coli, and ask, do they have the same proteins? Well, if they do, that's obviously interesting. It doesn't prove that they have anything yet to do with consciousness. Proteins can evolve by Darwinian pre-adaptations and their uses, but it's something that we can do. In principle, can we ask, do the mutant proteins fail to do something quantum mechanical, for example, a measurement that wild-type proteins do? Yes, in principle, we can. I don't know quite how we would pick out what quantum feature to look at, but I'm going to hint at one. I'll be telling you towards the end of this talk that there's some hint of superconducting behavior in quantum critical molecules, and we could look for that. That would be an extraordinarily interesting thing to look at. So there's a research program in front of us. It's actually already been done by a man named Luca Turin, who's selected for flies that are resistant to anesthesia, and he's finding anomalous electronic conduction properties in these mutant compared to normal flies, in the sense that they seem to be liberating free electrons. Now, I don't know whether or not to have confidence in his result, but they're certainly, again, repeatable. Now, so the next thing to tell you is that taking quantum mechanics seriously in the human body or in organisms was utterly dismissed a decade ago. I know I was told when I was asked by my physicist friends, don't be ridiculous, decoherence will happen within a femtosecond. There cannot possibly be any significant biological effects in quantum mechanics, of quantum mechanics. It turns out that that's wrong. About 8 or 9 years ago, it was discovered that light harvesting molecules are quantum coherent for 1,000 times longer than was thought, for a nanosecond rather than a femtosecond. And that's how it is thought light harvesting molecules have their quantum efficiency. It's because the photon, the photon excites an electron, and you have what's called an exciton, and it's trying to find its way a number of angstroms away to the reaction center. And rather than doing a classical hop, 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 hop to find its way to the reaction center, it simultaneously searches through all possible pathways between where it is now and the reaction center, and can do, therefore, a quantum speed up, so that the efficiency of photosynthesis is about 80 or 90%, whereas classical built devices are about 30%. So quantum biology is real. It's also almost certainly present in bird migration, and it may be present, and again, this is Luca Turin, in smell, where there is some evidence that it's not a receptor binding a ligand classically, but the receptor ligand is the pair is picking up a quantum oscillation. At this point, how far does quantum biology go? We simply don't know. Being open to it is the right thing to do, and we'll know a lot more in 20 years. And we will in particular, I think, because I'm now going to introduce you to my attempt to defeat Descartes. Remember, he stuck us with the closure of classical physics. I'm trying to get around it by going to quantum mechanics, and I hope I'm now going to succeed. I want to tell you about the poised realm, and I have about 7.5 minutes to do it. The poised realm is real, and it's a discovery or so that I have made with my colleagues Gabor Vate and Samli Niranan. So I'm going to use my hands to draw from your perspective. There's two axes, y and x, as you might guess. So y corresponds down here at the origin to quantum coherence. Let me tell you about decoherence. If you take a closed quantum system, it never loses phase information. If you open it up to the universe, acausally, with no causes whatsoever, the phase information disappears from the quantum system and goes out into the universe. When that happens, the interference patterns disappear. And it's been demonstrated experimentally over and over and over again. And instead of seeing an interference pattern in the two slit experiments, you see the two bands behind the two slits. There's no doubt about decoherence. It's absolutely real. What's less well known is that it is possible to get recoherence from something that is decohered to classicality for all practical purposes. You can come infinitely close to classicality. Nobody knows how to get classicality out of quantum mechanics, but you can get real close. But it's possible to get recoherence, the lost phase information, so that the waves no longer know their phases, that the heights and the valleys of the waves spread out in time and space don't know where they are, so you can't get an interference pattern. So by a theorem due to Peter Shor, it is possible to get quantum recoherence, and that's the basis of quantum error correction, the Shor theorem, in quantum computers, where you want to maintain quantum coherence to get the quantum computer to work, and Peter Shor's theorem is the basis of quantum error correction. Meanwhile, there's experimental demonstration of recoherence in the light harvesting molecule due to sound vibrations, which quantum mechanically are called phonons, and phonons can drive recoherence. And that's been now shown fairly convincingly experimentally. More precisely, and this ties into Stuart Hameroff, Gabor Vate and I are looking at studies of simulated quantum systems in which when you bring, with a sound vibration, if you bring two regions close together, they become quantum, and if you pull them further apart because it's oscillating, a phonon makes it oscillate, it goes quantum, classical, quantum, classical, quantum, classical. And you can actually see the oscillations in the computer simulations of whether or not the system is coherent. Phonons can drive decoherence and recoherence. That's essentially established theoretically very well, and it could be just what Stuart wants, for example, in the microtubules when they're squeezing closed and open and closed and open. The x-axis is order, criticality, and chaos. Quantum mechanically, well, classically order is a pendulum. Chaos is the onset of positive Lyapunov exponents where trajectories begin to diverge, and it's a single point on the x-axis. So if you look at the measure of the divergence in state space, the Lyapunov exponent, it stays 0 and it kinks upward at criticality. It's possible to measure whether molecules, quantum mechanically, not classically, are ordered, critical, or chaotic. This is just a staggering result. So the way you do this is for a molecule, you all know that molecules have absorption-emission bands. So take a molecule with, say, 100 absorption-emission bands and look at adjacent bands. Some of them are close together in terms of energy, some of them are far apart in terms of energy. Plot the distribution for that molecule, how many energy adjacent bands are nearby in energy, and how many are far apart. From your perspective, in the ordered regime, you get an exponential. Lots of adjacent energy bands are close together, not many are far apart. In the chaotic regime, you get a unimodal distribution, and for critical molecules, you get another unimodal distribution with the peak shifted in. You can absolutely tell whether a molecule in quantum mechanics is ordered, critical, or chaotic. So, Gabor and Dennis Salahab have now, with me hanging on by the skin of my teeth, analyzed about 300 or 400 organic molecules, including a number of proteins. The stunning result is half of them are ordered and half of them are critical, a single point on the x-axis. A few are chaotic, and the women in the audience will be pleased to know that testosterone is chaotic, which undoubtedly explains things that one doesn't really want to go into. So meanwhile, it's really true that half of the molecules we've looked at, including most of the proteins, but not silk, are critical, and critical molecules on the x-axis have anomalous electronic properties. They have fractal wave functions. There's a hint here of high temperature superconducting and anomalous electronic behavior that may bear on consciousness. So I'm now just going to try to say why we've answered Descartes and then stop. I have 3 more slides, but that's all right. Decoherence is acausal. Recoherence is acausal. That means we have a way for a quantum mind via the Poiseuille decohering and recohering to have acausal consequences on the classical meat of the brain. Meanwhile, I would like to suggest that on res potentia, res extensa, measurement itself is acausal in the sense that there can be no deductive mechanism that can entail the results of measurement. And it's very simple. The X is possible of res potentia does not entail the X is actual of res extensa. X is possible doesn't entail that X is actual. And if that's right, there can be no deductive mechanism that gives us the outcome of measurement. Nor have we found such a deductive mechanism since 1927. Therefore, my proposal of res extensa and res potentia is a scientific hypothesis. If anybody finds a deductive mechanism that makes the choice, I'm wrong. Okay, so it's an actual scientific hypothesis, not just philosophy. So to end what I want to say, We started with Descartes and the problem that we've been living with Descartes due to the causal closure of classical physics 350 years ago. Quantum mechanics opens the possibilities for a responsible free will because the present could have been different. Counterfactuals can be true. Furthermore, it can support Dean Radin's experiments because by quantum non-locality, which I think most of you know about, there can be non-local effects, and they're well established experimentally. And Dean's grandson's friend on Mars may have Dean's results from far enough away so that it's a non-local effect, in which case mind is quantum in part. But it also needs to be classical because you have to move muscles. So finally, measurement itself is almost certainly acausal. And if it's acausal, we have two ways to beat Descartes: measurement, which is acausal, and decoherence and recoherence, which is acausal. We're not stuck with Descartes 350 years later. Thank you very much.
All right, a few questions. Well, someone's coming up. I'll just say that mind needing to be both quantum and classical is accomplished by oscillating between quantum and
Yeah, right.
Yeah, okay. I can't see.
Can't see either.
Anybody here? Everybody's, there you go.
Yes, incredible talk, Dr. Kauffman.
I can't hear you.
Incredible talk, Dr. Kauffman. It's the person that sent you an email the other day. Anyway, I took on a label that I ascribed myself to be a quantum pharmacist after doing about 20 years of unusual research, and I've described what I call the syntropy zone as a place that's real similar to what you refer to as the poised environment, in a sense, where I found a way to cause a quantum effect physiologically from a mineral, classical side, and also from a quantum side using my mind. And I've been doing research with this kind of unusual stuff for about 20 years now. And I've come to a point, I finally am bringing some of this work out, and I'm trying to find some people to collaborate this with in taking this from a fruit fly into human tissue. And I found some ways, I believe there's some correlation to microtubules and OR theory, in that it's difficult to research what's going on in the brain, microtubules, etc. And I found you can perhaps research this in the connective tissue, which is full of microtubules, etc. I've done a lot of the research referring to numbness on tissue with regard to post-surgery problems, or say 30-40% of the people, say with breast cancer surgery, permanent numbness from the lymph node removal, etc. That can be reversed in about 30 seconds with a little device.
Could you ask a question,
or the
please?
mind. Yeah, my question is have you found any ways to correlate this beyond fruit flies into physiological jump ups, or step that up to a faster ways to apply application or give application to this rather than fruit flies, which can take another many, many years before there's human application?
So I don't have an answer for you, but if we take Dean's results, if they're repeatable, okay, and Dean would agree with this, I think I'm not insulting him, it's such an enormous result that it needs to be repeated a lot of times. Extraordinary claims require extraordinary evidence. Then, in effect, whether we like it or not, something like Dean's results are psychokinesis. Distant people are changing the behavior of a quantum system. So that's psychokinesis. Well, we don't think that that's right. We think it's nuts, but it may not be nuts at all. If mind is quantum, why should it be nuts? Therefore, is it possible that one can make devices, for example, that will have these kinds of effects? Sure, the field's just opening up, and right now I don't know any more than I think that, but good luck to you.
Thank you.
Sure,
Also create the same
absolutely.
results.
Yeah.
Thank you.
Hi, I'm very interested in the causal closure of the physical domain. So I understand the first part, that if like Dean's right and consciousness is collapsing the wave function, then that would be a failure of causal closure. But I don't understand the other side. So
What other side?
So when you were talking about decoherence and recoherence as a non-causal, I guess I just don't understand.
Well, that's,
Yeah.
I understand your problem.
Yeah.
I mean, the problem is that you know some standard quantum mechanics in which there's measurement and so on. Decoherence is something that people have been looking at for 30 years.
I know about decoherence, but
What?
I know about decoherence, but decoherence, I understand, is just another deterministic process that happens.
No, it's not. Decoherence is you open up a quantum system, and acausally and non-deterministically phase information is lost from the system into the universe. It's both acausal and not deterministic. And recoherence is similarly acausal and not deterministic. So a system can cycle between being decoherent and classical and recoherent and quantum, and nothing causal is going on at all.
So when you're talking about decoherence, you're not talking about like what Zurich is talking about when he's
What?
You're not talking about like what Zurich is talking about when he's talking about
I am.
decoherence.
He's a close friend.
Okay.
It is decoherence. Yeah. And if you look at what he will tell you is you take something, in effect you take something called the Lindblad operator, and it causes, doesn't cause anything. The off diagonals in the density matrix go away and you're left with the density matrix, but nothing causal has happened at all. And in recoherence, you would regain the elements in the off diagonals. Nothing causal has happened whatsoever, any more than anything causal has happened when the new store opens and it creates the possibility that you and I can go there and have lunch. We're absolutely stuck with thinking in terms of causes. If possibles are real, enablement becomes part of our explanatory framework.
It just seems like you're leaving out.
I think that somebody else probably ought to come. Thank you.
Brilliant talk, Stuart. Wonderful. Your observation on fruit flies and that they generate electrons is extraordinarily important. I've had, and I'd like further comments on it from you. I've had 3 graduate students gain PhDs studying the chi energy in human meridians. It's correlated in detail with electron activation at the ends of the meridians. There are other many measurements, many measuring instruments to do it. Only what you seem to indicate is that the chi energy has gone strongly up in the fruit flies.
So Alex, let's talk about it later, but it gives me the chance to explain a little bit more what Luca Turin has done. It's quite astonishing and needs to be reproduced. What he claims is the following. If you take normal fruit flies and you look at electronic conduction in the brain, you measure something. Now, I can just tell you he's using something that I almost understand. It's called spin resonance spectroscopy. I don't understand it. I'm not a physicist. His claim then is that if you anesthetize the fruit fly, the number of single electrons flowing goes up compared to non-anesthetized, as if the electrons are bound up in some state that isn't single electrons. Well, that suggests Cooper pairs, which are perfectly well known. Cooper got the Nobel Prize for it, which now become bosons, not fermions, and it's a Bose-Einstein condensate. Meanwhile, his other claim is that if you take flies that are resistant to anesthesia, that the flies that are resistant to anesthesia, when anesthetized, show a lot fewer free electrons. This is hinting at high-temperature superconducting. It's just a hint right now. But there's one other thing to be said. Our demonstration that a fairly large number of proteins are critical, first of all, that half of molecules are critical, the molecules we looked at, is staggering. Why should they be? But they are, at least of the almost 500 or so that have been looked at. Why? It's one point on the x-axis. It's right at the middle insulator transition, poised between conducting and insulating with these anomalous fractal wave functions. Given the anomalous fractal wave functions, there's just the beginning hint that that a protein that's critical may have anomalous electrical conduction properties that just maybe, very, very maybe, will hint of Cooper pairs. This is right on the sort of the horizon that can be seen now. If we should find that, then in addition to microtubules or within microtubules, it may be that what's going on has to do with Cooper pairs or essentially Bose-Einstein condensates, which I don't yet understand, but it can be tested. I mean, all of this stuff is objective. No matter what we find objectively, it won't tell us what consciousness is. But it may be the neural correlates or the neuropill correlates of consciousness, having listened to the talk that Walter Freeman would have given, but that Henry Stapp so sweetly gave. Yes, we should probably stop pretty soon.
Let me just make a comment. what you just said about superconductivity and anesthesia is consistent with what Anirban showed and what Travis Craddock showed. However, Luca Turin's results were at 6 degrees centigrade, and there's no if fruit flies were conscious, they would not be conscious at 6 degrees centigrade. So I'm not sure those are the best results. Let's have one more question, and then we got to cut it off.
Yeah, I agree with the doubts about Luca's results. Yes.
I was curious about your notion of the organic molecules being
your-
critical or not. Is this condensed phase, crystalline, or isolated molecules that you're talking about?
It's not crystalline. You can do it both calculationally and experimentally. Again, the experiment consists in taking a given molecule or a given identical set of molecules, whatever it is, phenylalanine, and you know experimentally, or you can compute with quantum mechanical computations, the absorption emission spectra. You look at the adjacent energy levels, and you plot how many are close together and how many are far apart, and how many are further apart, and you get some distribution. And the answer is that for ordered molecules, you get an exponential distribution. For chaotic molecules, you get a unimodal distribution. And for critical molecules, you get one where the peak has come in this way. These are done not in the crystalline form. Why in the world are half of the molecules we've looked at critical? Nobody knows. It may be that it's true of organic molecules in general, or it may be the case that selection has opted for molecules that are critical because fractal wave functions, for some reason, are incredibly useful. Nobody knows.
All right, before we thank our speakers, let me just say let's come back at 2:15 since we're a little bit late and we can spill over later. But now let's give a great round of applause to Stu Kauffman and Dean Radin for a fantastic session.